Hi, today we're going to see a short video introduction of alvaModel. alvaModel is a software by Alvascience. To check more Alvascience solutions, or for further contact, please check our site, alvascience.com. alvaModel is a software tool to create quantitative structure, activity, and property relationship models. In particular, it is focused on QSAR and QSPR regression models. alvaModel starts from two input files. The first is an AlvaDesk project containing the molecules you want to use and the descriptors and the fingerprints calculated on those molecules. The second input is a text file containing the target values you want to predict. The models created in alvaModel can then be exported in an AlvaRunner project. This project can then be applied to your molecules using AlvaRunner in order to calculate the predicted targets. This solution separates the training of the models from their deployment. Therefore, it allows you to deploy your models to other parties. alvaModel is available for Windows, Linux, and Mac. We start importing an AlvaDesk project. On the tree view on the left, we can see the software sections. In the Dataset section, a dataset called Master was automatically created. On the right, we can see the values of all the descriptors that are present in this project. We can now import the target values from a text file. Now, we're going to split the master dataset in the training and test datasets. In this window, we can change the percentage and the type of the splitting. Two new datasets are added to the Dataset section. We can now create a model selecting manually the variables we want by using a simple step-by-step procedure. This can be particularly helpful, for example, if we want to reproduce a model described in a scientific paper. In the first step, we select the type of model we want to build. The current options are a linear regression model, a KNN regression model, or a consensus regression model, which is defined as the arithmetic mean of the values predicted by other models. We now choose a linear regression model. In this step, we associate the training and test datasets to be used. Here, we can select the target value among the external variables we imported. We can also select the descriptors we want to use in the model among the ones previously saved in the original AlvaDesk project. The AlvaDesk project we imported does not contain fingerprints, therefore we cannot use them. In the last step, we can choose the policy to handle the missing values and some feature reduction techniques. The model created is added in the Model section of the tree view. Here we can see a table with a summary of the model, the type of the model, the number of columns, the scores for the training, the test, or all the molecules. On the right, we have a scatter plot where we can see the target values and the predicted value. And, if we want, we could switch it to show the residuals. Underneath, we have the table containing the target, the predicted value, the residuals, and the descriptors used in the model. If we want, we could add to the model an applicability domain. Or we could calculate other types of score. We can now try to find a model with more interesting scores by using the automatic models generation, which will start a feature selection based on genetic algorithms. Here, a similar step-by-step procedure will guide us. In the first step, we can select the parameters of the feature selection. For example, we can choose the score that will be used to determine the quality of the models. The following steps are very similar to the ones we already saw. We select, this time, a KNN model. We can specify a K and a type of distance. In this step, we can now select the descriptors that will be used by the feature selection. We select them all. And if we want, we could select a set of descriptors that we want to be present in all the models. We leave it empty for this example, but this time we decide to standardize the data. We can see that a new node was added to the model section. A counter is telling us the number of iterations done by the genetic algorithms and the best score found so far. We can pause this procedure and check the models found. We can save the best model found so far. At this point, we could decide to restart the feature selection procedure in order to look for other models. But for now, we stop here the search and export the models created in an alvaRunner project. We have to define a project name and, if we want, a project description. The alvaRunner project is now saved, and it can be used in alvaRunner. Please check the alvaRunner introduction video for more information.